We are working asynchronously, and it's kind of hard for me to say that. So we're going to go ahead and work on number 1. This is from your lesson dealing with trig application problems. Go ahead and take a second to read number 1. I'm going to read it out loud and you follow along with me. A fire started at a campsite located 8 miles from the base of a mountain. If the angle of elevation from the fire to the top of the mountain is 14 degrees, how high is the mountain? So go ahead and pause the video and figure out how you would draw the picture. I'm going to go ahead and give you time to do that. So we know that we have a fire that's right here, and we know that's it says we're located 8 miles from the base of a mountain. We will say that this is the mountain, and we're 8 miles away. We know that the elevation, the angle of elevation, that's a line of sight, is 14 degrees. And it's asking how high is a mountain. So you notice we form a right triangle. So we know that we want the opposite measurement, and we have the adjacent. Remember the mnemonic statement: sine is going to be opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Go ahead and take a minute to try to set up the problem. And like I said, we know the opposite and we know the adjacent, so we're going to use tangent. So go ahead and take a minute to set that up. I'm assuming that you paused the video. So what you're going to write, and I hope you did this, you're going to write tangent of 14 degrees is equal to the opposite measurement, which is the height of the mountain, over the base, which is how many miles it is from the base of the mountain. So it's 8 miles, right? So now to figure out the answer for the height, think about what are the steps that you need to solve this problem. So I'm going to go ahead and pause the video right now. Okay, so hopefully you remembered that you have to cross multiply. So you have 8 times the tangent of 14 degrees is equal to the height. So let's go to our calculator. So we have 8 times the tangent of 14 degrees. Remember that you should be in degrees, and I would have gotten the answer wrong since I had it in radians. Press enter. Go ahead and press quit, our second mode, and we're going to press enter, and that's going to give us 1.9, which is close to 2. So approximately 2 miles in height. For number 2, we have a man standing 85 meters from the base of a tower. If the tower is 200 meters tall, find the angle of elevation from the ground where the man is standing to the top of the tower. Make sure that you draw your picture. So we're going to go ahead and draw a picture. Go ahead and make sure you draw a picture. You have the tower. Here's your tower. Now we know the man is standing. The man is standing 85 meters away. And we know that the tower is 200 meters tall. So I want you to think about which trig function you're going to have to use to solve this problem. Are we going to use sine, which is opposite over hypotenuse? Is it going to be cosine, which is adjacent over hypotenuse? Or is it going to be tangent, which is opposite over adjacent? So go ahead and pause and think about what it could be. So I'm thinking we're looking for this angle here, and I'm going to call it theta. And I do know I have the opposite measurement over the adjacent, so that once again, that is tangent of theta equals opposite, which is 200 meters over 85. Now you might be thinking, okay, how do we do this? So go ahead and pause and think about how we're going to do this. We just finished a lesson dealing with inverse functions. So what you're going to have to do is you're going to have to get the inverse of tangent theta of the left side, and you're going to have to get the inverse of tangent of 200 over 85. Once again, as we did in the last lesson, you are given the input. So you're asking for the angle now, and that's what we're doing. So let's go to our calculator. I know some of you have Desmos, and you know how to do that on Desmos. For this calculator, we go second tangent, so we get inverse tangent. And remember, we're going to provide the ratio 200 over 85. And what's going to come out is the angle. In this case, we have 66.97 degrees. We're going to round it off to the nearest degree, so it's approximately 67 degrees. We're going to go ahead and do number 3. Now, these two problems have to deal with the angle of depression. So it says from the top of a lighthouse, 150 above sea level, the angle of depression to a boat at sea is 28 degrees. What is the horizontal distance from the boat to the base of the lighthouse? So I'm going to go ahead and draw the lighthouse. Here's the lighthouse. And we do have the boat that's over here, and I'm just going to try to draw the best boat that I can. So we know that it's going to be 150 feet. And we know that it's going to make an angle of depression. And this right here is the angle of depression. And this right here is a horizontal. And it's asking what is a horizontal distance. So we're looking for this distance. So remember that these two angles are the same. So think about what we're looking for. We know the distance. Oh, we know the angle. The angle is 28 degrees. So what I'm going to do is I'm going to go ahead and fill in what information I have. So I do know that this is 28 degrees. So take a minute as to which of the functions we're going to use, either sine, cosine, or tangent. You have opposite and adjacent, so what you're going to write is you're going to write tangent of 28 degrees is equal to the opposite, which is 150, divided by d, because we're looking for that distance. Go ahead and take a second to think about how to solve this problem. If you're deciding to do cross multiplication, that is a correct step. So you have d times the tangent of 28 degrees is equal to 150. And then what you have to do is divide by the tangent of 28 degrees. So the distance will equal to 150 divided by the tangent of 28 degrees. So what you're going to write is 150 divided by tangent 28 degrees. And I did make sure that it was in degrees. So your answer is, it's approximately 282 feet away. It says the angle of depression from a helicopter to a landing pad is 34 degrees, 54 minutes, and 8 seconds. If the horizontal distance from the helicopter to the landing pad is 1,200 feet, find the altitude of the helicopter. So I have to first convert it to a decimal degree. So as you can see, I did that there. What you have is you have 34 degrees plus, we know it's 54 minutes, and we know that in 1 degree there's 1/60th of a minute. So it's going to be 1 over 60 plus, we have 8 seconds. So it's going to be times 1 over 60 times 1 over 60. And why do we do that? It has to do with unit conversion. We know that 1 minute is 60 seconds, and we know that 1 degree is 60 minutes. So I'm going to go ahead and press enter. And so we get 34 degrees, 0.9. 34.9 degrees, that's what I want to say. So we have a helicopter. Here's a helicopter. And it's, we're looking from the horizontal. And we know that it has angle of depression. And this is the horizontal also. And so we know that this is going to be 34.9. And this is 34.9. And it says the landing pad is 1,200 feet away. So we're looking for the altitude as the height. Okay. Go ahead and pause and think about how to set this up. We're either going to use sine, we're going to use cosine, or tangent. So in this case, we're going to use tangent. Tangent of 34.5 is equal to opposite, which is h, over the amount of feet, which is 1,200 feet. We're going to make this into a proportion. We're going to cross multiply. So we have h is equal to 1,200 times tangent of 34.5 feet. So let's go to our calculator, and we have 1,200 times the tangent of 34.5, and so the altitude is 824 feet.